soccer. I'm tired of soccer. So here we go. Practice quiz. And up at the top, right below practice quiz, it says theta means degrees. So if I give you a question and I have a theta in there, that means I want your answers in degrees. Okay. Yeah. So the first one says find the inverse tangent of 0 without using a calculator. So we're trying to, so this is one where we say let it equal x. And then take the tangent on both sides. So we're looking for what angle gives us the tangent of 0. Well, what have I told you about when the ratio equals 0? What kind of angles are those? Quadrantals. So label your quadrantals. Okay, now, so the tangent is sine over cosine. Why am I thinking of it as sine over cosine right now? Because what do the quadrantals give me? They give us cosines and sines. So in order for it to equal 0, which one of these has to be 0? The sine. Why can the cosine not be 0? What happens when that's 0? It's undefined. Those are the asymptotes. So what I'm really looking for is when the sine equals 0. So what about right here? Yes. What about right here? What about right here? Yes. What about right here? No. So for your answer, you're gonna say 0 plus 2k pi plus 2k pi. Let me zoom out.
So if you put 2 pi plus 2k pi, that's still okay.
It's still fine. No, he said instead of 0, put the 2 pi. Yeah. Yes.
Wait, you know how in the quadrantals or whatever, like the first point is cosine, right?
Okay. The next one says use a calculator to find a 4 sig fig. So put this in your calculator. Make sure you're in degree mode. Okay. Just because I asked you to do something on your calculator does not mean it's free for all time. What'd you guys get? Oh, make sure you're in degree mode, or radian mode, I mean. Did I say degree? I meant radian. Ha ha ha. JK. Raffle. I meant radian, sorry. Should've got 1.133. Make sure you put 134. Make sure this number is right. Inverse tangent. You're in the right mode? You'll have to come to ask me later. Okay, hey! No. Don't round it.
How do you know whether it be in radians or degrees?
If I don't ask you, radians. If I don't give you a theta or I don't say in degrees, make it in radians. Is that okay? Okay. What are you gonna do here? They cancel, so it's just. Okay, what about for 4? Let Okay, I don't have to do this, but I'll give you the quiz tomorrow. I'm tired of the conversations. So you're going to let the x equal the inverse cosine. And what are you going to do with the inverse sine? Y equal inverse sine. This is where you have the two triangles. So really what we're looking for right here is we're looking for the sine of x plus y, which is and it's an identity. It's the sum identity. So it's sine x cosine y plus cosine x sine y. And we know this stuff because we're going to use these here to make our triangles. And now these may not be nice numbers, and that's okay. But when I say without using a calculator, what I mean is I want the square roots in there. Okay? You're not going to get to... I don't want decimal approximations is what I'm telling you. Okay? If you need to use your calculator to figure out the missing side length, that's fine. But no decimal approximations. So cosine is adjacent over hypotenuse. So what would the missing side be? Hypotenuse squared minus the other side squared? Square root of that? What's 121 minus 36? I don't know. 85. Square root of 85. Just leave it. Are you okay there? And then here, oh, it's positive, so that's why I'm drawing these in the first quadrant. So 9 minus 4 is square root of 5. So don't forget, this is your x triangle, this is your y triangle. So instead of the sine of x, what is the sine of x equal to? So look at your x triangle. So square root of 85 over 11. Good. Now, did we just replace x or replace the sine of x? Sine of x. That's the ratio. Times the cosine of y. So look at your y triangle. So root 5 over 3. Plus the cosine of x. Good. And the sine of y? Good. I will ask you to work this a little bit. When you have the square, when the indexes are the same on the square roots, you can multiply the number underneath. 85 times 5. Root 425. I'm pretty sure it's not nice. Over 33. Plus 12 over 33. Which is the same as root 425 plus 12 all over 333. You can leave it there. I'm not expecting you to simplify the radical. But I'm ask you to understand that you can multiply it if the indexes are the same underneath.
Do we have to take the sine of that? Oh, never mind.
Are we good?
Yeah.
Okay. Okay. Everybody okay with question 4? We've done something like this very similar quite a few times. Okay. Question 5. Also relatively, it's very similar. This one you're not going to get a nice number answer. You're going to have x in your answer, and that's okay. So, once again, we're going to take just the inverse part. I'm not going to let it equal x because I already have an x over there. I'm going to let it equal y. You could let it equal t if you wanted. You could let it equal a theta. I don't care. Whatever you want.
How can we take the why didn't we bring the 2?
Because now we have sine of 2y. That's a double angle. And I don't want to bring the 2 because then I'm talking about a half angle over here, and I don't want to deal with half angle. Is that okay? And so the double angle is 2 sine of the angle, cosine of the angle. And this, now we can use this to build our triangle to replace these ratios. If you brought the 2 with you, you would have had to have divided by 2, so you would have y over 2. You'd be talking about half angles. You don't want that. Don't do it. Gross. Okay? Okay. Are you okay with what I did to here? This is why you get your black bar sheets, because we still have to use our identities. Okay. And then from here, we're going to build our triangle. So the sine of this angle is equal to 1 over x. And we always draw these ones in the first quadrant. So tangent is opposite adjacent. And then use Pythagorean to find your hypotenuse. Do not break apart that radical because there is a plus sign in there. You cannot pull the radical apart when there's a plus in there. We good there? Okay. So now we're looking at 2 times the sine of y. So use your triangle. So sine is opposite over hypotenuse. Times the cosine, which is adjacent over hypotenuse. And I do ask you to multiply this. What's 2 times 1 times x? 2x. And the square root of that times the square root of that. It's just 1 plus root, or 1 plus x squared. The square roots cancel. And that's your answer. We good there? Okay. 6 is similar, but we're actually getting a nice number answer from the first few we've done. So what we're gonna do now, arc secant, does that change anything? No, it's the same as inverse secant. So we're gonna let this equal x. So really we're looking for the sine of x. We're looking for that ratio. So what are we going to do with this? No, not multiply by. Take the secant of. It's different. Okay. So the secant of that angle is equal to that ratio. Now, because we started with an inverse, where does the inverse secant live? Look on your black bar sheet.
1 or 2.
1 or 2, and it's negative, so it's going to be in 2. And secant is hypotenuse over adjacent. Notice, where did I put the negative? Did I put it with the hypotenuse or the adjacent? The adjacent. And then there's your opposite. And we're looking for the sine of that. So what's the sine of that? 3/5. That's your answer. Are we okay there? Okay. Example 7 is like what we did in 5.3. Find the exact solutions of over all real numbers. So this is the plus 2k k pi stuff. So, sine of some angle is a negative root 3. So, we got to figure out where the sine is negative. So, is this quadrant 3 and quadrant 4. So, those are the 2 places we're going to draw our triangle. Very good. Sine opposite hypotenuse. That's just the first triangle, right? I'm just doing one at a time. So what's our reference angle? Not 6? Pi over 3. The root 3 and the pi over 3, they go right across from each other. So we're 1/3 more than pi. So what's the full angle? 4/3 pi. So that's the first one. Is that okay? Bless you. And now the fourth one. Opposite. Hypotenuse, adjacent. What's our reference angle? Pi over 3. So what's the full angle? We're 1/3 from 2 pi. pi over 3. Good job. Yes.
Why do you use negative square root of 3 over 2 instead of just instead of just negative square root of 3?
And the hypotenuse of 2?
Yeah.
It doesn't matter.
Doesn't so either one? And
Yeah, it's the same reference triangle.
okay, that's what I thought,
Yep.
but I was just never sure.
The reference triangle, the difference between the one that this one and this one is it's just a scalar multiplier. They're still similar triangles. And they still give you the same angles.
Okay, that's what I thought. Because it always came out the same, but I never thought.
Yeah. Remember when you did geometry, when you did the triangle shortcuts? ASA, SAS, those ones?
Yeah.
That's, and we're going to get into that in the next chapter as well. But it's all based off triangle congruencies. And so the angles are going to be the same as long as the sides are proportionate to each other. And this one is just double this size.
Okay, that's what I thought.
Yeah. Yeah, good question. Question 8. What can you say about the sine of x equals -2? Is there a unique solution? That means one solution. No solution. Or infinitely many solutions? No solution. Because so sine and cosine, they max at 1 and min at -1. Well, this is at -2. So if you drew that wave, would it ever cross? No. So your choice here would be B. No solutions. We good there? Okay. Question 9. Mark all of the solutions. So one, all, none, multiple, odd number of these might be might be a correct answer. Now we are only looking for one rotation through the circle, yes? Okay. So in order to solve this, what's causing us the biggest problem right now?
Cosine of 2x.
The cosine of 2x. Now you have double angle identities. The other trig function that's in here is a cosine. Use the one that only has a cosine in it when you replace the double angle. I can't remember them all, so I have to look at them too. Yep. So you're going to write this 2 cosine squared x minus 1. That's the double angle. And then this. So replace the double angle. And then just write it in the right order and combine terms if you can. And really what we have is, we're treating it like a quadratic. So either factor it or quadratic formula it. Are we good to there? And then what property do we use? Zero product property. So we say that 2 cosine x plus 1 equals 0, or cosine of x equals 1 plus 1 equals 0. So this one is when the cosine of x equals a -1/2. That happens 2 places. Or the cosine of x equals a -1. I always want to start here. Why do I want to start there? It's a quadrantal. Here it's 1, 0. Nope, that's not right. This is 0, 1. Nope, that's not right. Oh, -1, 0. That's what I want. And 0, -1. Nope, not what I want. So I want this one right here. So what angle is that? Pi. Oh, there it is. So circle E up at the top. That one worked. And now for this one, I have to do 2 triangles. So where's the cosine negative? Which 2 quadrants? 3 and 2 and 3. 2 and 3. If you need to draw this, draw this. Cosine, cosine. So quadrant 2, quadrant 3. We'll do it this way. works the same. So what's across from the square root of 3? Pi over 3. So what's the actual angle, though? Oh! So what's the actual angle? 2 pi over 3. You're 1/3 away from 1, right? So here's another answer. Yep. Because you're going to have the exact same triangle down here.
But then you just add another.
You have the same reference angle, so now we're 1/3 more than pi. So, and think of pi as 3 pi over 3, so 4/3 pi. Oh, there it is. There's your 2 answers. Or 3 answers. Sorry. Is that okay? Okay, question 10. So, in order to solve this, it's kind of a lot like the other one. Now, notice theta. So, we're asking degrees. And we don't want all answers. We're in an interval. What are we going to do? What's the problem? We have the sine squared and there's just a cosine. Can we change sine squared in terms of cosines? Pythagorean. So instead of a sine squared, it's 1 minus cosine squared. So then what? Distribute. I hate negative leading coefficients, so I'm moving all this over here. And then either use quadratic or factor. And then zero product property. So cosine theta equals 1/2. Bless you. Or cosine theta equals a -1. So where's cosine theta equal -1 at? Pi, which is the same as 180 degrees. That was a quadrantal. We just did it up above, yes? Okay. This one, up above we did the -1/2. This one's +1/2. So, where's the cosine positive? 1 and 4. So, in the first quadrant, cosine adjacent, hypotenuse. What's this angle? 60 or pi over 3. So there's another one. So we have 60 degrees. And we also have in quadrant 4. So 1/2, 1√3/2. So this is 60 degrees, but we want the whole angle, so you're at 300 degrees. There's your 3 answers.
What would that look like if you did the Pythagorean?
You would end up with 1/2 and -1 after you simplified it out. After the quadratic. That would be your B, B1. Your A is 2. C is -1. When you simplified it all the way out, you'd end up with 1/2 and -1 is your answer. Is that it? Is that it? Wow. Is that disappointing? Okay. Okay. Don't freak out.